It's off by one at a time.
And that is totally unstructured. We have those big tables in the back that's set up for everyone.
Sure.
And you come and you eat free pizza and you work on whatever you want. And it's somebody a fellow Python users. And this is a great opportunity for people of all backgrounds. General Python community announcements. So the largest annual Python conference, PyCon US, which happens to be in Montreal next year, is happening in April of 2014 in Montreal, and registration opened today. So if you are interested in attending a Python conference where you can see tutorials and talks and poster sessions, you can sprint on your favorite open source projects. This is again an event that is appropriate for people of all programming and Python backgrounds. There's tons of beginner material, intermediate material, expert material. It's a really fun conference. If you're sitting here thinking, okay, Python conference sounds pretty nerdy, it's really fun. It's a really great community. It's volunteer driven, so people are very invested in this being a great experience for everyone. There's everything from a young coders event, free programming for kids, to an actual physical sprint, like running a 5K, just to all kinds of great stuff in Montreal.
And they give you t-shirts that you can wear for years and years.
That's true. So if attending PyCon sounds interesting to you, there's a fixed number of early bird tickets. So it's in your interest to sign up now while the cost is cheaper. PyCon is it's run as a nonprofit conference, so it's as cheap as it can be to cover costs. It's like $300 for individuals. So for up to 7 days of conferencing, you don't have to go to all of it, but the thing spans 7 days. That's really a pretty good deal. And it could really not be easier to get to Montreal. It's like a 45-minute plane ride.
The proposal for talks has closed, but you still have until the middle of October to propose a lightning talk, which for the first time this year, they are taking some proposals for lightning talks ahead of time, rather than having them all be ad hoc in the conference. So if you have something you would like to say for 5 minutes to 2,000 people in Montreal in April,
About Python.
about Python probably, you should propose a lightning talk.
And a great thing about being a part of this user group is that we give you plenty of opportunities to practice, so we will rehearse the talks and lightning talks in the months ahead of time. Pretty great.
Right. Yeah, it's
and
awesome.
I'll be there, he'll be there,
Totally.
that guy will be there. It's a good time.
Yeah.
Any other announcements? I think that's very good.
That's it. We had free pizza. The pizza tonight was bought by Insight Squared. And this is Chris, and he's going to explain why.
Hi, Insight Squared. Where's my speech? I've forgotten it already. I guess people. Yeah, we provide. Beg your pardon? We provide. Yes, exactly. No, we help small companies take on and take down their largest competitors by arming them with elegant, powerful business analytics. We grab data from sales, marketing, financial, customer service data from SaaS APIs like Salesforce and Google Analytics and QuickBooks, and provide over 400 beautiful visualizations and analytics. We're a startup. We're well funded. We have over 300 paying customers. We are 60 people in one office between here and Central, and we are 17 engineers, all of whom push code on their first day. We're very fast-moving company. Here at Python Django Shop. If you'd like to have more information, check out our dev blog or grab one of us slides. We'll be here in the bar. Thanks.
Thank you so much. There's also going to be an opportunity for free beer after this event. We'll talk more about that at the break.
We're totally going to Meat Hall for free beer, so you should come with us.
Okay, so the structure for tonight is that there are four talks on fundamental topics. So we'll do two, have a break, two more, and then beer. First up, a man who needs no introduction, our very own Ned, is going to be talking about names.
And values.
Names and values.
Wait, Giles, how do I get a browser on this thing? Hi, everyone.
Hi, Ned.
Language coming from other languages, and they get a little bit confused about how names in Python work. And the extreme example of this is when some Python people will say that Python has no variables. And this really angers me, frankly. Computers are usually an emotionless, dry subject, but when people say Python has no variables, I feel like they are being intentionally obtruse. And I want to explain what's going on here so that you'll understand it, and the next time someone says Python has no variables, you'll understand what that person means. He's very well-meaning, but it's not a really great way to look at things. So let's talk about what happens in Python programs. In Python, you can have names, and they refer to values. So when we say that x equals 23, what we're saying is that 23 is a value, it's an integer, x is a name, and the assignment statement makes x refer to 23. So that in the future, if you use the x variable, it will give you back the value 23. And in these slides, I'm going to make diagrams of how this stuff works. And the names will be these rectangles on the left-hand side. And the values will be in circles and boxes on the right-hand side. And there's an arrow between them to indicate that the x refers to 23. The title of the talk is Facts and Myths About Python Names and Values. And every slide is a fact that you can take as true. And it's not a fact with an asterisk, like, mostly, usually, kind of, sort of. It really is always true. And if you think to yourself, I know enough about Python to know that that slide isn't always true, then you need to re-examine what you know about Python, because the facts on these slides are always true. Now, the thing about names is that many names can refer to one value. So when we say that x equals 23, we get the name x referring to the value 23. And then when we say y equals x, that makes the name y refer to whatever value x refers to. So x and y both refer to the value 23. Neither one of them is the real name. Neither one of them is the better name. They are both exactly the same. They both refer to that value. When names are reassigned, they're assigned independent of what other names might point to the value. So if we say that x equals 23, and then later we say that y equals x, now when we say x equals 12, no one expects y to now equal 12 also, and that's true because when you say that x equals 12, it takes the name x and it points it to the value 12, and y is completely left out of it. This is a very important fact and one that confuses people. Assignment never copies data. So if we take a list called nums, we have a name nums referring to a list 1, 2, 3, I should say, and then we assign other equals nums. Just like with the integers, we have two names referring to the same list. So nums refers to a list, and other refers to the same list. There is only one list, because neither of these assignment statements copied any data. And since we only made one list with the 1, 2, 3, there's only one list. And this is where it gets confusing, because if you change a value, then that change is visible through all the names. So if we assign 1, 2, 3 to nums, and then we assign nums to other, now they both point to the same list, and then we append 4 to nums, that has modified the list that nums refers to. It is also the list that other refers to. So we've appended to nums, and we print other, and we see the change. Now if you remember on the integer example, where y was not equal to 12, the reason is that when you have integers, you are always assigning new values to things. With lists, you can modify the list in place. If we had to pick a culprit in this slide, it would be that dot. Because that dot means do something to the value. Nums is a list. It has a method called append. We're going to call that method, and that method might change the value in place. And if that value is referred to, you'll never get into this problem with strings, because strings are immutable. And I don't mean people generally don't change things in strings. I mean, literally, it's impossible in Python to change the value of a string. Any operation you do on strings actually makes you whole new string objects. Same with integers. When you say x plus 1, you're not changing the integer in place. You're taking x, you're adding 1 to it, and making an entire new integer to represent that value. So the first myth we're going to come across is sometimes when you'll see people trying to explain this to people, they'll say things like, well, the way assignment works in Python depends on whether you're dealing with mutable values or immutable values. And that's not true. Names refer to values precisely the same way for both immutable values and mutable values. It's just that if you have immutable values, there's no way to get into that tricky situation, because if you remember, the mutable presto changeo requires you to have a value referred to by more than one name, and then the value has to change in place. Immutable values never change in place, and so you never see this tricky behavior. That doesn't mean that assignment is different. Assignment is exactly the same. It's the changing that's different. And that makes perfect sense. The whole name of the categories of types has to do with their changeability or not. They are mutable or they are immutable. Another thing about the references is that we've talked about names as references, but lots of things can be references in Python. So for instance, if you have a list, nums, which is 1, 2, 3, it actually should be drawn like this. I've been drawing the list with the numbers in the little boxes, but in fact, lists are merely arrays of references to Python objects. It's a lot more compact to put the numbers in the boxes, but in fact what's happening is the list is a list of 3 references, and here they refer to 3 distinct integers. And in fact, we can assign x equals nums sub 1, and that means that now we have the name x referring to the same thing that the second element of the list refers to, the integer 2. So names can be references, but also list elements are references. Lots of things are references. Object attributes are references, list elements, dict values, and the keys are references. Anything that can appear on the left-hand side of the assignment statement can be a reference. So you have object attributes, you have dictionary keys on values, you have list indexes, and then arbitrarily complex expressions that combine all those things together. So all of those things are references, and assignment works the same way for all of them. It turns out in Python also that lots of things are assignments. So we've talked about the x equals expression style of assignment statement, but all of these statements in Python where that capital X appears, that's where a name can be, and that name is assigned to. So in fact, when you create a function, def x of something, what you're really saying is x equals this function thing. And the way that name x behaves is exactly the same as if you used x equals blah, blah, blah. So def is an assignment, and class is an assignment, and the iterator value name in a loop is an assignment. When you import a module, you're assigning an object to a name in your code, and so on and so forth. And again, I don't mean it's kind of like because we defined a name. It's exactly like that. These names all become references to their values, and those values all keep track of how many references they have, and they all go away when the names go away, and et cetera, et cetera, et cetera. Now, of all of these that we just looked at, the trickiest one is the argument to a function. So here I've got a function that takes an argument x. When you call that function, the actual value that you put in the function call gets assigned to the name of the argument. So for instance here, we have a function of x. Whoops, let's reload that. Sorry. So we have num is the integer 17, and we're going to call a function with the value of num. And what I've drawn here is every time you call a function, there's what's created is a thing called a frame, which holds a bunch of names. And when you go into a function, there's a whole bunch of new names that are available to you. And when you leave the function, those names all disappear. Right? Variables local to a function are available to you while the function is in effect. And when the function's done, the names all disappear. So I've put all of the names that are going to be inside the function in this dotted rectangle labeled func. So func has the argument called x. When we called the function, it actually assigned to the name x. So num referred to 17, and because we called func of x, func has a local name called x, which also refers to the number 17, because the assignment statement works just like all the others that we saw. Calling a function assigns the actual parameters of the function call to the formal argument names of the function definition. And then you can use the names, and then when you return from the function, that whole frame for the function goes away. Any names that are in there go away. Any values that were referred to by those names decrement their reference count. Any values that no longer have any references are cleaned up, and so on and so forth. In this case, it was all very simple. No new values were created. But going into the function and having a new frame that has new names that refer to values by virtue of the assignment that happens during the function call is a very important mechanism to understand. And I'm going to show you now 3 examples of a function to do a very simple thing, some of which work and some of which don't work. And they're the kind of function that people write where they get tripped up by the behavior of mutable values being passed around. And we'll talk about why they do what they do. So the function we're going to try to write is a function called augment twice, which takes a list and a value, and it's going to tack that value onto the end of the list twice. So here we have our list nums. We're going to call augment twice with nums and 7, and since we've passed in nums as the first argument, it gets assigned to a list, and 7 gets assigned to val. And so we see the effect of that down there. A list refers to 1, 2, 3, and val refers to 7. When we append val onto the end of a list, you see that we're modifying the list referred to by a list. We've appended a 7 onto the end. We do another a list.append of val. It gets another 7 on the end. And now we're going to return from the function. And so the entire frame, it should all disappear down there. There's some rendering issues. The entire frame is evaporating out from under us. The names are going away. The references that those names held are going away. The values are all taking into account what's happening to all their references. And by the time we come back from the function, nums now has 2 more 7s on the end, right? So that works great. We've augmented nums. We did just what we want. We took nums, we tacked 7 onto the end twice, right? Simple. Let's write that function a different way, right? New guy sitting next to you says, oh, that dot append is kind of clunky. Why don't we just add on a little new tail of the list that's got the 2 vowels in it, and that'll work great. I'll just change it for you. Well, you know how new guys are. So we'll take nums. It's got 1, 2, 3. We're going to call augment twice bad, right? So it's assigned nums to a list and 7 to val. And this statement, a list plus val comma val, that expression, the addition, makes an entirely new list. And the assignment, a list, points to the new list. Right? So now a list refers to a brand new list. Nums, up in our caller, still refers to 1, 2, 3. And now we're going to return. And you can see what's going to happen. When we return, the frame evaporates away, the names evaporate away, any values that don't have any references also evaporate away. You can see our hard work disappearing before our eyes. It's very demoralizing. And when we come back out of the function, we look at nums, and nums is 1, 2, 3. Didn't work, right? So it seems like a very small change, right? If you want to add 2 elements to the end of a list, you can either append to it twice, or you can assign to it the addition, et cetera, et cetera. It should be the same. It's not the same. And the difference is, again, the dot. So the dot append means you're modifying a value in place. You're calling a method on the list, it's modifying the value in place, and that gives you different semantics than using the plus operator, which will create you an entirely new list, which you can then assign unto the same name, but that might not be enough to get the effect that you need. Luckily, the third way we're going to write this function will also work. So augment twice good, we're going to take our same 1, 2, 3 and our same nums and comma 7, and we'll be in here with a list and val pointing just the way we did. And now we're going to do the same plus operator that we did before and assignment. So now we have a list referring to 1, 2, 3, 7, 7. But notice that we're going to return a list. So the frame down here has a little reference to the 1, 2, 3 because the frame knows that it's got to hand a value back up to the caller. And when we get back down into here to nums to the function call, the assignment is going to make nums refer to that returned value. Right? And so this has the effect we want. Nums is now 1, 2, 3, 7, 7. We had to make it be an assignment to nums, but we got the effect we want. And by the way, notice that because we didn't modify any mutable values in place, this function could be part of an even larger program that's sharing values all over the place. Maybe our first augment good is exactly what we wanted, except that someone else who was referring to that 1, 2, 3 list didn't want it modified. This is the best way to write the function, where instead of modifying lists in place, you just make new values that are the way you want, and then you pass them around. We're essentially treating the mutable values as if they were immutable values, right? We're not changing any of the values in place. A few more facts about names and values. Any name can refer to any value at any time. This is what is referred to as dynamic typing. So for instance, if we assign x equals 12, and then we assign x equals hello, and then we assign x equals 1, 2, 3, and then we change
the second element of x, that's all fine. This is not four examples of 4 different statements from 4 different programs. This is a valid 4-line Python program. The fact that x used to be an integer and then was a string and then was a list is perfectly fine. There's no reason you can't do that. And really what it comes down to, and this is a kind of pithy statement that occurred to me as I was working on this piece, names have no type. So in Python, when you say x equals 12, the 12 is a typed integer. The x doesn't care. X is perfectly happy to refer to 12, but it's also happy to refer to a string and then a list and whatever. Conversely, values have no scope. So by scope, I mean that when you call a function and the names that appear and disappear as the function is entered and left, that's called a scope. Values have no scope. So the values you create in a function can last beyond that function if you pass a reference to them outside the function. So over on the left-hand side, we have names in a nice little stack with the scopes outlined. But over on the right-hand side, we've got values, and notice that the references can go any which way. So names have no type. They can refer to any value at any time, but they come and go as functions are called and left. Values have types. You know, it's definitely an int, it's definitely a list, it's definitely a string. You can't change a string into a list. But they have no scope. Their lifetime depends entirely on what names are referring to them. And we've seen examples here of values going down into functions, values being created in a function and going back up to the caller. So names and values are actually pretty simple. The people who get confused by them are people coming from other languages, notably C. They don't have a monopoly on the word variable. Python has great variables, and don't let anyone tell you any different. By the way, if you want to try out some of these things, there's a great site called Python Tutor, which can do this kind of stuff, but dynamically, where you can actually edit this code and then start doing, this doesn't quite fit on the screen, I'm sorry, but let's see if I can, yeah. You can step through forward, and it kind of draws these same kinds of diagrams with the line going up and down the code as you do it. They're not as pretty as my diagrams, but they'll work on your code, whereas my diagrams are kind of labor-intensive to create. So Python Tutor might be a good way to go if you're interested. Don't know how to get back to my other window. There we go. That's it. Any questions? Any questions? Jessica, how much time do we have for questions?
I don't know.
You're supposed to be keeping track of these things.
We didn't agree on that. What time is it?
It is 7:33.
Great. You have 2 questions.
2 questions. So we don't know how long all these things will take. We may have time at the end for a sort of general open-ended questions. I will also be at Mead Hall, and I will not be drinking beer, so I will be sober the entire time. So I can answer any question there as well.
Oh, crap.
Y equals x. So what happens if I have y equals x dot copy?
So it depends entirely on what x is. Well, no, it doesn't depend on what x is. It's going to be a separate copy, right? You ask for a copy of x, right? If the x is an immutable value, then there's not much point and also not much harm, I guess, in copying it. If it's a mutable value like a list or a dictionary, you'll make an entire copy of it. Lots of people reach for copies when they get into these problems, and it's generally much better to reach for making new values. So step away from mutating values and step towards making new values, especially if you feel yourself stepping towards copying values. The problem with copying values is you'll probably end up doing it way more than you need to, and you'll eventually also move from the soft drug of copy to the hard drug of deep copy. And the problem with deep copy is that it's definitely going to copy more than you want it to. So you really want to think about what's mutating your structures and keeping that under control rather than adding a lot of copies.
One more.
One more.
Are your slides on a PDF somewhere?
My slides, so
Sorry.
We'll make all the slides today.
we will, but if you want to go there now, so these slides were based on a long blog post I wrote, which is at bit.ly/pynames, if you want to go read about it. It has pros. And we'll make the slides available.
Great.
Great.
I have one quick announcement. This is sort of a depressing announcement. And the reason I'm giving you this announcement is because you are here, if you are likely to show up to other Boston Python events or have friends who show up to Boston Python events. You may have noticed that Microsoft Nerd is becoming increasingly emphatic about having identification when you sign in downstairs. So, unfortunately, I was just in quite an episode trying to get some of our fellow Boston Python members up here who did not have IDs, and they would not let those people up. So they are dead serious about it. They gave me the following quote, which is really pretty sad, but tells you how serious they are. They said that a Turing Award winner was coming here for a banquet, and that person forgot an ID, and they didn't let them in either. So bring an ID, tell your friends to bring an ID, and we'll definitely send mail about this as well. Eternal
All right.
sunset.
Who's next?
I'm next.
Okay. And now a woman.
A lot of people, in particular folks who have not had formal computer science training, are like a little fidgety about, or it seems kind of hard and kind of academic. It's a really useful core skill for leveling up your Python and general programming. So we're going to spend a couple of minutes talking about when to use important data structures and how to evaluate when to use them in your code. Also known as, why is my program taking forever to run?
Oh, feel free to use the clicker.
Oh, I don't trust clickers. I don't. Okay. Okay. Let's set up a seemingly really simple scenario. All I want to do is I want to look up a bunch of words. Let's say that I have a master word list. Maybe it's a Scrabble dictionary. Maybe it's a list of names or places, and I want to look up a bunch of stuff in that master list. There are a lot of, that's a reduction of a lot of potential programs any of us might need to write. So let's say that we want to do that, and here is like a really simple possible way we might write this. Maybe we have this master list of words, all words, and we have my words that I care about, my words, and just to make it the simplest possible exercise, let's say I want to know how many of my words are in the master word list. So here's one possible way of doing this. I suck up all of the words into two lists, I have a counter, I say for every word in my list of words, if that word is also in the master word list, increment the counter, and when we're done, print the counter. Okay, like, definitely one really simple way to do this. Okay, I feel good about this. Let's do it. Okay, we're gonna run this. I should say that the master word list has about 100,000 words in it, and my word list has about 50,000 words in it, which is not tiny, but it's not a huge amount of words either. In fact, the official Scrabble dictionary has over twice that many words in it. It has over 250,000 words. Okay. Okay, well, I don't know about you, but I'm pretty impatient. So if we're going to run this, at the very least, I'm going to time how long it takes. And fortunately, in Python, this is really easy. There's a really simple module. There's this time module. We import it. We get the start time, do a bunch of work, print the difference between the current time and the start time, and we have a really simple in-program timing mechanism as we play with the timings for various things. So if we were to run this, how long does it take? That's in seconds. 65 seconds for looking up 50,000 words against a 100,000 word list. Again, it's really not that much data. Computers are supposed to be good at this stuff. What is taking so long? Okay, well, I've heard about dictionaries. I know I can look things up in dictionaries as well. For fun, why don't we try doing this with a dictionary? I mean, I don't know if it's going to make a difference. Let's try. So we're going to construct a dictionary from our word list. Just do a little for loop to construct the dictionary first. And then the only change we're going to make in the meat of this, in the body of the for loop, is to look up the word in the word dictionary instead of the word list. Okay, I don't know if this is going to help, but let's find out. How long does this take? Okay. I like that a lot better. I'm patient enough for this. And in fact, if we take a bunch of different timing measurements, if we keep the size of my word list the same, but we change the size of the master word list, and we do a bunch of timing runs, like 100 words, 1,000, 10,000, 100,000, these are the times that we get. There are actually two lines on this plot. The dictionary one you can't see, because it's at the very, very bottom here, taking about 0.01 seconds every time. Whereas the list version clearly seems to scale with the size of the master word list. And to make this a little bit easier to see, we could do a log-log plot here. This is the same data, but plotted with the log of the size of the dictionary versus the log of the time, just so we can actually see that line. Okay, well this is a huge difference. I mean, like, this is the difference between me completing my research paper and not. And we're only at 100,000 here. Like, what if I had 1 million words to check against? Or 10 million? I mean, that's totally plausible, right? With a lot of science experiments, analysis of data from the internet, I mean, that we're still in pretty small territory here. So what is going on? Well, to figure this out, we need to think about how in Python you look stuff up in lists and dictionaries. And we don't have to care about the super nitty-gritty details, but just at a high level conceptually, what does it mean to look something up in a list? You have a list of items. They're unordered. So to figure out if a particular item is in the list, to figure out if eggplant is in this list, I potentially need to sort of traverse, to iterate over, to look up item by item, up to every item in the list, trying to find the one that I care about. So another way of sort of phrasing this is that the amount of work that we have to do to look up an item in a list is proportional to the length of the list. Why don't we give a variable named n to the number of items in the list? We say that then it's proportional to n. Finding an item in a list takes on the order of n work to do. And this notation here has a very specific computer science meaning, but the way that we can think about this is we have to do about n work on average for this operation. Okay, so looking things up in a list takes effort on the order of the size of the list. It's order n. What about a dictionary? Well, we might have to do a little bit of research to figure this out, because it's actually pretty complicated under the hood. But at a high level, under the hood, looking up an item in a dictionary is sort of equivalent to this diagram. When you set up your dictionary, you have things arranged, sort of in a row. And you can index into each item, each key value pair in the dictionary. But when you do a lookup, you have a thing you want to look up, and you do this transformation on it under the hood. You do this transformation that will pop out the index that you need to look it up. And this is pretty fast. This takes a constant amount of time. That's pretty small. So you push in, you have the thing that you want to look up, out pops a number, and then you don't have to search around for what you need. You just pull it out directly. You don't have to iterate over everything in the dictionary. So another way of discussing that is that the amount of work that we have to do is constant. It doesn't matter how many items are in the dictionary. We just have to do this fixed amount of work, applying this hash function to the input, and that produces our output. So we might say that finding an item in the dictionary is on the order of 1, or on the order of a constant amount of work. It's independent of the size of the dictionary. Okay, so armed with this sort of notation, armed with this sort of understanding of the way that lists and dictionaries work, why don't we analyze what is going on with our really simple example? So all we had is a for loop. We said for every word in my list of words, let's get a new variable there. Let's say that m is the number of items in my words. So we're going to have n loops, n iterations through the for loop. For each loop, we are going to do order n work in the list case. Because we know that looking up word in word list takes on the order of the length of the list. So for every iteration through the loop, which we do m times, we do n work, or to put it all together, we're doing order of m times n work. So this is our sort of runtime analysis for the list case. And we can do the same thing for the dictionary case. Looks very similar. We still have m items. We have the same number of my words. What changes for the inner loop is how much work we do for the lookup, right? So this is constant time, order 1. M times 1 is just m. I like m. M is smaller than m times n. That sounds pretty good. And this analysis makes a lot of sense if we go back to our plot here. Because what we're varying along this axis is the number of elements in the master word list. And we see that this one is constant with respect to n, with respect to the master word list. This one grows linearly with n, with the size of the master word list. So this is good, because our timing analysis, our just thinking about the problem, these graphs, they all match. This means that we probably understand how much work we're doing for each of these two for loops. So that's pretty good. And we can do this analysis for lots of other types of for loops, lots of other types of algorithms. What you have to do is either memorize or be willing to look up the costs of some basic operations, typically on the size of the amount of information that you're working with, the number of elements in the list, the number of elements in the dictionary, or you sort of derive yourself from an understanding of the way that Python implements things, how expensive these things are. So we already saw that looking things up, that finding things is order n for lists. It's constant time, order 1 for dictionaries. Inserting things at arbitrary places in lists is order n. It's constant time for dictionaries. Now at this point you might say, well, lists are kind of crappy. Like, why? It seems to always suck compared to a dictionary. Well, okay, but to be fair, lists can do things that dictionaries don't know how to do, right? Lists have an order, which can be awfully convenient. If you ever need to sort things, you can't use a dictionary. You might want to use a list. So when you find yourself dealing with slow programs, or just wanting to understand better the runtime of your programs, you're armed with a couple of things. You have this time module that you can use to profile, just really simply profile your code. You generate some simple graphs, maybe with matplotlib. You memorize or you look up the costs in basic operations, and you just do that very simple analysis. Where's the for loop? Where's the repeated work? How expensive is that work? So there's nothing particularly magical or particularly scary about it. You just do it systematically, and it can be really illuminating for speeding up the code that you're writing. So here's what I ask myself. Here's what I encourage you to ask yourselves if you find yourself debugging a slow program. Number one is, what operations am I using a lot? Am I repeatedly looking stuff up? Am I repeatedly sorting stuff? Am I repeatedly adding stuff to the end? What are the operations that I'm doing frequently? And then given that explicit information, what data structure makes those operations fast? Maybe you actually be using that data structure instead. And then the specific case that we've seen here is that repeated lookups tend to imply using a dictionary. Dictionaries are really good for looking stuff up. Okay, so that was a good sort of introductory analysis. This is an endless topic. There are lots of other useful data structures. Depending on what you're doing, you might find that a set is useful. A set is like a dictionary, but you only have unique values. You don't have repeats. Tuples are like lists, but you can't change them. They're immutable. And this can be really useful on a totally different axis. We've been talking about how long it takes to run things. A totally separate but equally important concern is how much space your programs take up. And tuples can help you save space because they don't have to carry the extra baggage associated with being able to mutate the data structure. If you find yourself writing programs that deal with a lot of data, maybe you're doing scientific computing and you're creating a lot of objects, or you have a lot of stuff that's really complicated and takes a long time to run, you might find that you need to launch a broader investigation into high performance computing data types. So for example, if you've heard of the NumPy or SciPy libraries, they have special data structures that have been finely optimized for doing various types of computations. If you want to learn more about this stuff, sort of in a structured way from a book, there's a book called Think Complexity by this guy, Alan Downey, who is a professor at Olin College, and he's a Boston Python member, and he often comes to user group events. He's the guy who wrote Think Python, and if you have read that book. And so this is another book of his that is an introduction to complexity and analyzing data structures and algorithms. And then two other recommendations. Going on right now on Coursera, which is an online learning platform, there is an introductory algorithms class and a sort of algorithms part 2 class that are both quite good that you might be interested in checking out. They're happening right now. Okay, so here are the take-home points. Sort of analyzing your programs and figuring out why they're slow and making them faster is not particularly hard or scary. It just requires being systematic. When you're picking a data structure and an algorithm, ask yourself, what operations do I use a lot, and what data structures can I use to make those operations fast. If the code is slow, do a basic runtime analysis like we did. The m times n stuff. Look at the for loops, figure out how much work you're doing, and come up with sort of the overall complexity, and then figure out how you can reduce it. And use the time module to time things and get a sense to reinforce your gut check that's here. So use all these things together, and the next time you have a slow program, you'll fix it. It'll be great. So that's it. This is a very simple, basic, whet the appetite introduction to this topic. All of the images are courtesy of a very funny webcomic called Hyperbole and a Half. And given all of that, does anybody have any questions?
Like when you're dealing with big data sets, do you recommend any of these approaches that you discussed, or would you use different?
So the question was, let's say that you're working with a ton of data. Like we're on a whole other level here. Do you use different techniques, or do you use these? You use these. Like this is how you get the first sense of where things are slow and what needs to be fixed. You think about it. You look at your code. You think about the common operations. You do a little bit of profiling via print statements, via these timing calls, and armed with that information, that's usually all that you need to do to make forward progress. From there, you can use more sophisticated techniques to use a real profiler, stuff like that. But I mean, I personally do this stuff on a daily basis whenever I need to speed up my code. Back here?
So, how much time do I lose if I actually start the dictionary? Because the list is usually very, very simple to implement. The dictionary takes some time to create, right? And I have to have the hash files, the hash values.
Yeah, good question. So the question was, well, you didn't include the cost of constructing the dictionary in your timing outputs. Is that really expensive? And I did that intentionally so that we could look at the graphs very directly, just the cost of the for loops. Setting up a dictionary is very cheap. The dominant cost is actually reading stuff into a file. So between constructing the dictionary and getting all the data off the disk part is the way more expensive part. But again, this is what's cool about this is that it would be so easy to figure out. If we would just add some time to print statements, then we can make a judgment call from there about what is too expensive. But good eye. Yeah.
How does your hash function come up with 4?
Yeah, good question.
What was the question?
The question was, how does my hash function come up with 4? It was a nice small number for my diagram. If you're interested in this stuff, a really interesting exercise is looking through the Python source code to see how these data structures are implemented. It's a really interesting exercise. Because this stuff is like a hash table is a complicated data structure to get right. It's interesting to see how the Python core developers did it. So my made up hash function made it the number 4. But the Python implementation will do a really good job for you. It'll be very fast. Yeah.
Can you say a little bit about how big your set would have to be before you start getting hash collisions?
Sure. So there's a question about hash collisions. What I'm going to do is I'm going to deflect that comment because I want to focus on those sort of very introductory comments. But what that really is a comment about is if you're interested in figuring out how these data structures are implemented under the hood, I totally recommend going through an algorithms textbook, a data structures textbook, or taking a class. Because the stuff is fascinating. There are all kinds of interesting things you have to worry about when you're implementing these data structures for real. It's very cool that in Python we don't have to know any of that stuff to fruitfully use these really high-level data structures. So this is sort of the beauty of Python, is that we get these constant kind of lookups with no work involved. That's very cool. You don't get that in C.
In fact, the chart you showed shows the collision starting to occur. That's why the number went up a little bit.
Sure. For the beginners in the room, you get constant time lookups, and that is awesome. Let's use dictionaries for everything. Other questions, comments?
Is there a useful profiler for Python?
I don't have a favorite Python profiler. Do you?
There's one or two in the standard library. They're all a little clunky, but.
I mean, like the dirty answer is I use print statements to profile 99.9% of my code. But there are Python profilers. Like if you wanted to do that, or just to have the experience to see what the output looks like, there are profilers in the standard.
There was a nice tutorial last year at PyCon
about profiling Python application. There is
Cool,
the
excellent
video
PyCon
online.
flag. So all of PyCon's talks and tutorials are made available online. So there was apparently a PyCon tutorial from last year on profiling. If you could follow this. Last one.
If
Anyone
there is
wanna
one.
take it?
No. All right, thank you, Jessica. All right, we're going to take a small break now, but I have an unusual thing to say, which is there are two people in the back of the room that I did not know were going to be here tonight. And their names are Brandon Rhodes and Raymond Kettinger. And if you don't know their names, you might want to look into it, because these questions about how do dictionaries really work and when do the things happen, Brandon did a really awesome talk at PyCon about exactly those details. And Raymond kind of implemented it all. So one of the guys that actually builds core Python and does all the data structure is sitting back there. That's Raymond. He's responsible for a lot of the awesome work that comes through Python. You should totally go and talk to those guys, because they showed up here like, I don't know where they came from. You can talk to them. Huh? Brandon's there too. Stand up, Brandon. Yeah, Brandon's awesome. All right.
As a quick follow-up plug for this, if you've ever wanted to contribute to Python, like the Python that we know and love, there is a core mentorship mailing list that is all about helping new contributors to the language get started. So if you've ever wanted to contribute to an open source project, or Python specifically, check out the core mentorship mailing list. It's a very friendly way to get started.
All right, we're going to take a quick break, have some more pizza, get some drinks. I know you're thirsty. We'll be back here in less than 10 minutes for the next talk.
So 10 after. 10 after we're starting.
10 after we're starting.
Which is what?
Yeah.
I'm going to put a bunch of these out on the pizza table at the end of the session. So please take stickers and things to write on at the end of the meeting. Are you ready?
I'm ready.
All right. Let's
I was
give
born
books
ready.
away.
Let's give some books away. You guys don't sound very excited. I love reading. Okay, so the way we're going to give books away, we're going to use the meetup.com API to get a list of the people who said they would be here tonight. And if you're thinking this through, you know that if you said you were going to be here and you're not here, you might be embarrassed. And if you have crashed by saying you didn't say you were going to be here, you cannot get a book. Raymond and Brandon, you cannot get books. All right. So from tonight, import people. Okay, so we are contacting meetup.com. We're asking them who's out there, okay? And we have a list, right? So here are people in our list, okay? We're going to import random.
Wow. You will definitely know Python.
These are really big books. We're going to shuffle the people, okay? And then we're going to make a thing which is an iterator over the people so that we can pick people. And we will say next pick is someone named Muthu. Is Muthu here?
Yeah.
All right. Muthu gets a book. So come up and choose a book.
Your two options are Learning Python by Mark Lutz or The Python Cookbook by Dave Beasley and Brian K. Jones.
Okay. We have 3 of the enormous thing and 1 of the only huge thing. Okay. Samuel Murphy. Come on up. You don't get a choice now. They're all the same, but
Also, you have to read the whole thing.
Clara.
This could be a quiz next meetup, right?
Oh, yeah.
Clara.
Yay!
And someone named Mike Woodward.
There we go. That's 4 for 4.
That's
Not bad.
yeah. Mike, we're going to raffle off a space for your name, too. I don't know why that's like that, but okay.
Thank you.
All right.
Congratulations.
Great. That's it.
All right. Thanks, O'Reilly.
Thanks, O'Reilly, for donating the books.
Yay.
Ooh, my thumb drive is corrupted. Okay. All right. Giles is going to speak to us about virtual env and pip. Correct?
Correct.
Okay. Let's actually give you a mic.
Correct. Hi, everybody. I'm curious. First of all, show of hands. Who uses virtual environment? Yeah, good health. Good. 50% of you. And so, I'm guessing the rest of you, you may have either poked at it or seen it a few times, but maybe never explored it for what it's worth. So, uh-oh. Attention. All right. We're in the Microsoft Center, right? We can get some support for this. Oh, good God. Yeah, I'm not sure what happened here, but let's see if this does anything. Nope. All right.
Let's raffle off the stickers.
Yeah, please.
Call your actions on left and virtual end.
That's a good question. All right, let's try it one more time. Oh, I know. Yeah, no, all right. Well, we're going to have to look at small slides. Is that all right? Can we see everything?
Can you put the notes down and close up the...
Yeah, that's a good call. All right, let's see. Yeah, bigger.
Then that little up triangle on the right-hand side. And then make the maximize browser thing.
And then full screen it. Full screen it there.
Yeah.
I love this. I love this error message. Attention. All right. So virtual environment. This is kind of more of a. This is less to do with Python in that We're not going to be talking about language specific details about data structures or how names work, right? I mean, the two previous lectures were very much about nuances within the language. I mean, we'll talk a little bit about one nuance, but for the most part, this is much more of a mechanical artifact of Python, of why these tools exist in the first place. And just as kind of a heads up, my demo is going to be very Unix oriented. I'm what the command line will look like when it started, but an important attribute within that module is called path. And that path is the list of directories that Python, the executable, will look through to find your module. So when you say import my module, Python will go through and look at each of these directories to look for a file called mymodule.py. And if it finds it, it's like, hey, I found it, and it will import that. It will open that file, evaluate the Python, and then put that in your local namespace. But if it isn't in one of any of these directories, it will give you an import error. And so this is really the, in Java, it's class path. There are, these kinds of dynamic languages. This idiom persists. And so for Python, you need to, if you need to import a module from a a directory that isn't baked into the compiler ahead of time, then you actually need to modify this list. It's a list, as you can see, right? We can see the brackets at the end. So we can modify this. We can add things to it. We can subtract things to it. The other thing to know is that if you have two modules of the same name, the one that wins is the one that appears in the list first. So if it's in this first directory and also down here, this one will win. So most and this kind of presents a problem as far as how do you then modify Python to import a module that you have downloaded specifically for your project? Excuse me. There are a couple solutions, there are a couple workarounds for this. Particularly, so you can imagine that if you're on a computer that you don't have system administrator access for, if we look at most of these directories are system level directories. They are not directories that we can modify as a general user. And so without having root access, our only other workarounds are to, first, we can alter the environment variable Python path. That is the shell environment variable. That augments that list before the Python interpreter ever starts. Second, we can just alter sys.path by ourselves before we import our code, right? We have to add something to the list and then say import. We can't do it the other way around because Python won't know about it ahead of time. And those are, they're cumbersome and complicated. So the third solution is to use this virtual env tool, which is written by Ian Bicking. And that tool provides us a means to create our own sandbox that we can administer. So this sandbox it's independent, it's lightweight. And when I say lightweight, so the Python library, it's huge, right? It's got many megabytes of code in there. And so when you create a virtual environment, it will do its best to create a mirror of that environment inside, say, a home directory that you can administer. And so under Unix, it will just be a series of symlinks that point back to regular system Python. It's which is to say that you can create a number of these virtual environments and not worry about, for example, it becoming an impact on your quota or something along those lines. So, and it doesn't require that you have system administrator access. And the other great thing is, so as I said, you can create many of these, and that's really powerful. It's a very powerful idiom. At work, where I work, we have a number of Python environments that we provide for our users. And one of the environments is our stable branch of our code. Another environment is our production or our development environment. And so you can think of these kinds of environments as hermetically sealed from one to the next. And even though they have this, even though they may have the same names, it's all about which environment that you have initiated that dictates where you're going to pull code from. So if you don't have virtual environment installed, it's a command that you can more or less just run right at the command line. Here we can quickly see a demonstration. So if you don't have this command, if it's not available, then you can run and install the virtual env burrito. And this is a simple shell script that will download all the necessary tools for you, and it will get in virtual environment started within your home directory. There are a few other paths. I just want to mention them quickly. You can use easy install, which often ships with most Python distributions. Or you can just go ahead and grab the code yourself and install it yourself. But that's involves a little more yak shaving, if you will. It involves a little more work. So, my argument is go ahead, just try this burrito first. See if that fits the bill. But once you have it installed, that is, once you have this command, virtual environment, then you can start going ahead and creating your own environments. So what is required to deploy an environment? Just a directory name. It is really simple. So I can say virtual env my-env. And as you can see, it does a few things, and it talks to you about it, and once it's all done, then you have a directory called my-env. Now, I don't know if you... I'm sorry? The font. Yeah. Probably.
It's Command Plus.
Command Plus, all right.
Sweet.
All right. So you may or may not be familiar with this Unix command called which. Which is similar to import in this respect, in that what I'm going to be asking my shell to do is look through my my path. So let's look at our path quickly. Oops. So my path has a few directories within it. They refer to mainly system level directories, user local sbin, user local bin, etc. So if I ask Python, or if I ask, my shell, where is it finding Python? It's going to tell me user bin Python. So that's not my virtual environment Python, though. That's not the Python I want to execute when I'm executing within my virtual environment. So what I have to do is activate my environment. This is another unicism, which is that I'm prefixing my command with a period here. And what that tells my shell, which is what I'm operating in, is to evaluate the script and modify my local environment. So I'm going to say dot tilde, with tilde refers to my home directory. And you notice that my prompt has been changed, and this is really helpful. It tells me that I'm now within my environment virtual environment. So now if I ask Python, or if I ask my shell the same question, which Python would you execute if I just type in Python? It tells me that it's going to execute from mount space home ghall myenv bin Python, which is different from the first Python I showed you, right? And if we look at path, we can see that my path has been changed to reflect the first directory that we're going to hit is this bin directory that is created specifically for my virtual environment. So when so this is to say that this Python that I'm going to be running has been slightly altered from the system level Python, so that when I import things, they will come from my virtual environment. And we can just go ahead and verify that. So I'm going to say deactivate. Deactivate is comes with virtual environment. It says, okay, I want to get out of my virtual environment. I just want to be back to standard Python. And we can verify that with our which command. So if I say Python, and this is now, remember, this is system Python, I import sys, and I ask sys.path to see where is it going to pull modules. It's just a bunch of system directories. If I enable my environment and ask it sys.path, look at, see that the second element in the list is reflective of my virtual environment. So the first thing I'm going to check before I check all the other directories is my local environment first. And this is helpful because now I can install packages. Now I can install my web stack or my database hooks or what have you, without having to beg the system administrator, please install this for me. And the other key thing is that I can also create many different installations of slightly different packages that then allow me to test. For example, if I want to see if this environment versus this environment is faster, I can slightly alter the code and deploy them into two virtual environments. And so I can create, they're basically, you can think of it very much as a controlled experiments where everything is the same except for some little bit of code. If we look at the environment itself, just within the directory, it creates a small set of directories within there. And as you can see, so a bunch of these Python files, they're symlinks, right? They just link right back to, they link right back to system Python. But I don't know if you've ever had this happen to you, but you are using a system, something that's provided by Python, and it's not working for you. You don't understand what's going on. Let's go ahead and say that that's, let's see, stat.py, for example. If what we can do is we can copy it in that way. Now when we import stat.py, we're not importing it from the system anymore. We're importing our local copy. And so we can make changes. We can insert print statements, and we can modify system-provided code ourselves and see how things are working. This is just a wonderful debugging technique in that respect, because you don't have to alter a file that everybody sees. You can alter a local copy. So that's how you deploy. You can also activate an environment within Python. That is, we can start from the Python interpreter, the system level Python interpreter, and then we can import a Python file that is part of the virtual environment. And that will alter our running environment to reflect the fact that we want to use our virtual environment. So this is very handy. So if you are, for example, deploying a web application via WSGI, WSGI isn't going to know ahead of time that you want to use a virtual environment. But if you put in some code that is similar to this code, you can tell WSGI, no, I actually want to use my virtual environment, not the system level environment. Virtual env, the command, provides a number of useful command line arguments. And I just wanted to mention a few of them that I find that I use a bunch. So if you've installed a bunch of global packages on your system, then you can say -- system site packages, and that tells Python to look, when it's within your virtual environment, it will look at the global environment to see if it can satisfy a module request first. And that way, if you can have you can defer, you can say, you know what, don't worry about my local environment, look at the global environment first, and then go local if you can't find it. Dash relocatable says that if you created your virtual environment in your home directory and then you move it, if you don't provide this command line option, it's going to break. So relocatable says, I want to be able to move this directory anywhere. I want it to all be self-contained, essentially. And dash prompt just allows you to alter, as you saw when I initialized, or when I engaged my virtual environment, it changed my prompt. So this allows you to tailor that so that you can make sure that as you're typing commands, it tells you which environment you're in, which can kind of be a gotcha if you mix up which environment you're in. This is kind of a side quest, but there is another command called virtualenv wrapper, and that can sit on top of virtualenv. And this makes it easy to manage many different virtual environments. It comes with a bunch of neat little tricks. For example, you can set up hooks within your shell so that as you cd from one directory to the next, it will automatically change which environment you're in. You can define environments by name as opposed to where they're located. You can delete environments. It's a rich tool set. It's very thin, but it's a nice little wrapper that makes maintaining your virtual environments that much easier. These are some of the commands that it comes with. So I'm going to switch gears quickly and talk about Python packages. So all of this is really kind of, all this really centralizes around this idea of how does Python import code, that is import modules or import packages, and what, how does it find it, etc. So a lot of this boils down, many years ago they came out with distutils and which was kind of an easy way to, if you're a developer and you come out with this really slick package and you want other people to use it, another file that you ship with it is this file called setup.py. Probably you've all seen setup.py in one way or another. Setup.py tailors or dictates how Python should install that package on your system. It also gives a bunch of meta info, like what is the name of the package, what's the author, etc. Typically in a normal source, non-virtual environment, when you say Python setup.py install, it's going to try to install that in some system level directory. But not with virtual environments. With virtual environments, when you when you install packages via setup.py, it will install it instead inside your local environment, which of course you have permissions for, and so you can administer. So this is it's good to know that Python packages exist and they have the setup.py, and that they more or less install within whatever your library directory is, whether it's a system level library or down in your home directory. And in order to make packages easier, Ian Bicking, who also wrote Virtual Environment, wrote pip. And pip is this Python package management tool. So setup.py is great for installing packages, but when you want to uninstall them, it's nowhere to be seen, really. And so pip, on the other hand, sits on top of setup.py and works with you to install packages and remove packages and upgrade packages and give you a list of all of the packages that you have installed. Pip will query the Python cheese shop for you. So the Python cheese shop is a nice repository of all of the available packages that you can download and install. There's thousands of them. Pip will you just need to know the name of it, and Pip will just go ahead and install it for you. pip, much like virtual environment, it has a series of commands. One of them is install. So you can say, and so I have a package I use commonly. It's called peewee. So I can say pip install peewee, and it runs out. It downloads it. It downloads the most recent version of it. It unpacks it. It sets it up for me, and so now it's available for me. Let's just go ahead and just see that, in action. So I'm in my environment now. Remember, I set up this thing called my environment. And then I say pip install peewee. Very quick, right? Just runs out, grabs it, downloads it, and then we're all set. And so if we, and just to kind of prove to you, so I'm currently in my virtual environment. So if I run Python, I say import peewee, it imports it just fine. In fact, we can ask Python, there's this magical dunder variable called __ file that we can use to query where did you import this code from. And as you can see, we imported it relative to my home directory. Now, I'm just going to go ahead and deactivate my virtual environment and say import peewee. Whoop, no module named peewee, right? Because now I'm using system Python and it doesn't know about my local environment anymore. So, so I obviously need to be within my virtual environment in order to be able to import that. The other really cool thing that when you set up a virtual environment, you should notice that, as you can see, it says right here, installing pip. So that pip, that one that I would be using, is hardwired to my virtual environment. Much like we'll say which Python, we can say which pip, and as you can see, it's running pip within my virtual environment, and that pip has been slightly doctored to be aware of the fact that it should be installing packages local to my virtual environment and not into the global Python, or not into the system level Python. So pip is incredibly useful. You can use it not just to install specific packages, but you can use it to install specific versions of packages. So I can use this syntax, package equals, and then the version number. And as you can see here, I'm installing version 0.1 of peewee, and it has no problem doing that. I can also use it to uninstall peewee, which is great, right? Now you can not just, it's not like as soon as the package goes in there, you're done. You have to either, toast it from orbit or go in there by hand and delete it. You can actually ask pip to uninstall it for you. So, which is to say that pip actually has a list of all of the packages you've installed. And this is kind of helpful that, you could imagine that if you have on your home computer come up with some really slick web application, but it depends on, Lord knows, maybe 8 different packages. One of the commands that pip comes with is a list. And that allows you to say, what are the packages that are installed on my computer or within my distribution? And that you can crystallize and then deploy on, say, Amazon or some other environment. So it makes it very easy for you to tailor environment specifically to your development needs and then crystallize that environment so that you can distribute it as a complete application in other contexts. And that's about it. Any questions?
Two questions.
Two.
Thanks. So let's say that you are trying to set up a virtual environment and also initialize a Git repository.
And also initialize a Git repository.
Yeah. Which one of those would you do first?
So your virtual environment is kind of independent of your repository. Your code, for example, so a common idiom is when I make my scripts, and this is actually something I should have mentioned. How do you start your scripts? A lot of people just say this: pound bang user bin Python. The problem with this is that now you're hardwired to system Python. So instead, a more common idiom is you'd see something like this: user bin env Python, which says, hey, I don't know where Python is, I'm delegating to the shell. Let the shell figure it out. And this is exactly how you should start virtual environment compatible Python scripts, essentially, which is don't hardwire it to a specific interpreter, just go ahead and delegate it. So less about Git, but more about how should you write your scripts so that they will pivot dependent upon how the environment is wired. Does that answer your question? Sure. But come see me afterwards.
How can I share my virtual environment with somebody else?
That's a great question. So as long as they don't need write access to your virtual environment, and your permissions are set up in such a way that they can read and execute items out of your directory, you just need to tell them the path. And then they can use the same activate or activate this in order to be able to engage your virtual environment. The problem is if they need to install packages. And so now you're kind of back into the same problem where somebody else, where you use a virtual environment to get around the fact that you can't modify system Python. In that case, you would need to leverage Unix permissions in order to be able to create a writable environment, or you would use the pip commands like freeze to be able to crystallize your environment and share it with somebody else. But then it would be two independent environments that you would maintain.
Okay, thank you so much. We have one more talk this evening.
In a minute, we're going to have Deb talking about how to find information. Don't forget that when we're done here, we're going to Mead Hall. And what's at Mead Hall? What kind of beer? Free beer. The beer is because of Sarah. Sarah is on the lab.
Oh.
Hi everybody. Yes, so I'm going to be buying everybody their first drink at Mead Hall, or for those that come out. So yes, a lot of labs. Has anybody heard of us before?
Woohoo!
Okay, there's not a lot, so I'm glad I'm here. So we do hosted continuous integration and deployment. So we would replace like a Jenkins or a TeamCity. We auto-parallelize the test suite. Basically, we make your test go really fast, and we provide you with a bunch of really cool, methods around the test. We just took like an 18-hour test suite and made it run in 12 minutes. We were pretty proud of that. Just announced New Relic as a customer. They're building their product completely on us. So if you use New Relic, they use us. So check us out, and if not, just come get a beer and do on the program.
I don't know what it is.
Yay, thank you.
All right. If you don't know where Mead Hall is, we'll be walking over there in bunches afterwards, about 9:15 or so.
All right.
Go Deb.
All right, so I'm going to go kind of, this is very beginner type thing. This is something that I always struggled with when I first started learning to program. Like, where do you guys find all these answers? Like, what would happen all the time is someone would like turn the computer around and like tap, 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 tap. And they'd be like, oh yeah, I found out what it is, it's this. And I'm like, well, cool, it's fixed, but now I don't really know what you did. And it's sort of the same when you're programming. Like, you might see someone else's code and you're like, wow, that's great, but how did you know where to look for that? So maybe you're new and you don't know where the questions are, or maybe you're really tired and it's late at night and you forgot where all the answers to all the questions are, or you feel alone and sort of, like, how will I ever get out of here? So I am a non-expert, so in addition to sharing the places where I know to look for questions, I asked some other folks where they go looking for the answers to their questions. So I'm going to share some of those. At the end, there's a slide with links to some books. I haven't read all 5 of those books, but other folks swear by them, so you'll have to go and look at little bits and pieces of them on your own. So the first thing I learned was that it's really important to be asking the right question. So you can spend a long time asking the wrong question and then you won't get the right answer, which seems kind of obvious, but then how do you do that? The first thing you want to figure out is if you can replicate, like whatever is not working for you, try replicating it. So sometimes you want to try it with like a different data, like if you're, like, oh, every time I put in like the entire sum of human beings on the earth, like this thing breaks, and it's like, well, try it with the number 10 and see if it still breaks. So maybe, maybe that's where part of your problem is. Or, you know, if it's like, oh, every time I put the name with the umlaut in, like, that might clue you in. So, like, you know, put something in without umlauts. All right, so then next, try picking apart the error message. Sometimes if you get the same error message over and over again, it starts to be like the number on a book page, and it just is like not real words anymore. Like, you know, kind of try and step back. Go look at the line number that's referenced if it's that kind of error message and see what's going on there, like regardless of it, what you understand about what it was trying to tell you. And then finally take a break. I think food and coffee are really good when you're stuck. Maybe you don't have time for that. Maybe you promised you'd do something by the end of the day. But you should at least try turning everything off and turning it back on again. If people watch the IT crowd, woohoo! Yes, okay. So this is really critical because, like, so Giles just showed us all this virtual environment. Maybe you were trying to do something like fancy and cool, and you cloned your program like 8 times, try all these different versions, and you forgot that you were in the one from yesterday that doesn't have access to any of the stuff you need. You turn it off, you turn it back on again. Oh, shoot, I've been working in the wrong directory for like an hour. Problem solved. All right, great. So after you figure out how to ask the right question, we want to ask the right question in the right place, right? That makes sense to everyone now? All right. Cool. So I don't actually know why you would want to put fire in a bucket, but we're going to put questions in the bucket. So the first type of question that you might have is something that's got to do with your tools or your environment. So like as much as you can to try and tease out, like, you know, if like, did it work yesterday on a different machine? Then it's probably like a tools and environment question, right? The second would be like something specific to Python programming, and that's probably like the bulk of like what folks here are looking at. But occasionally you have something that's project specific. This is maybe not so intro, but you might find that when you're kind of going into like a new project from a different programming language or something. So questions about your tools or environment. And I'm going to put up links and then I'll make the slides available, so don't try and take like really super fast notes, because it's going to be sad. You're going to see the links page and you're like, what? But I will definitely make the slides available, I promise. Okay, I'm on the board at Open Hatch, so I happen to think we have some really nice tutorials for learning how to use collaborative tools. So like if one of the things that you're doing as a beginner is collaborating with folks on a free and open source project, but you don't know how to use IRC, or you don't know how to use Git, or you don't know diff patch, all that type of stuff, there's tutorials on that over there. And the folks in the channel happen to be really friendly, so you can always come into that IRC channel. IRC and Git themselves, like if you go to those websites, like for freenode.net, which is where a lot of the projects I look at are, or for Git, you can find help or tutorials specifically for those tools. So you don't have to just like help internet. You can go somewhere specific. If you have questions about how your programming environment is working with your operating system, there's usually help for that too. I happen to be using Linux, so I go to Linux questions. Whatever your operating system is, there's probably something similar. I always assume because there's more people not using Linux that there's plenty of websites for you all. Yeah? Maybe? All right. And then also all of the editors and the development environments have their own FAQs. So we'll just go through some of the links. Open Hatch, like I said, Freenode. I looked at a lot of different Git tutorials, and this one actually I think is probably the best. It was written for students. I think like when you do documentation, you should try and do it when you're still like, I don't know if I totally get this, because otherwise you write documentation where you're like, so starting at step 3 after you're a genius, here's how you tweak it to make it extra awesome for geniuses. Which is not like what I'm looking for when I don't know. I've seen so many books and I'm like, are we missing chapter 1? Did it fall out? Like what happened? But this one seemed really good and had like a nice table of contents on the side, so you could skip right to the part you need. Like I said, linuxquestions.org, tons and tons of questions, like literally everything from like, you know, like how do I install something to make my sound card work, to stuff that's more specific to programming, but like they go deep. There's Emacs and VI, both have their own resources for looking at editor stuff, so maybe you saw a friend like do something really cool, and you're like, how did you do that? Where you just like yanked one line and then like cut and pasted it somewhere else, and so you can go back and find out like how you do that. IPython, a lot of folks really like this environment. I haven't used it. And then finally, if you, for whatever reason, decided to use Eclipse for your programming environment in Python, and there are projects that do this, like the Sahana project, that's their default. Everyone has Eclipse, and so a lot of the stuff, like nice pointers to where you want to look in the code, are sort of Eclipse specific. But again, students to the rescue. Some folks at Berkeley wrote a really nice thing, how to set up Eclipse to use with Python. So, and like I said, I'll make this available. So Python specific questions. Python's own documentation happens to be really awesome. I say this as a recovering Java student. The Java docs suck. And we can't even blame it on Oracle. Like, Sun wrote them and Oracle just sat on it. So they continue to suck and be out of date. So, as a comparison, the Python documentation is awesome. You guys are totally picked the right language. And so, right within it, like whether you can either go out to the Python website and look at stuff, or you can ask about stuff while you're in Python. So like the random, this is what Ned used to make the Raffle work. Woo! Woo! So dir is sort of the quick and dirty, I guess. It tells you all the commands that you can use with that one. But if you need more help, more verbose help, the help will also tell you stuff about any particular kind of module or library. So in addition to that, Stack Overflow, if you have not gone there as a beginning programmer, you're welcome, and also I'm sorry. So the bonus, your questions may have already been answered. Like, it's a very busy website. It's kind of like Grand Central Station for programming questions. The minus is it's mostly dudes on the internet. So if you're in the insanely an amazing position of helping an 11-year-old learn to program, dudes on the internet. I would check the area they're looking at first. So also they will not do your homework. And they get really angry if they even suspect that you might be trying to get them to do your homework. So if you're scrub out all those weird variables where it's like 2 trains, I'm trying to write a library that calculates how they are going at 2 different speeds, and when they'll hit, and they're like, you're doing your homework, we're not doing it. And they will never answer your questions. Not that I've done it, but I've seen the vitriolic conversation that ensues when other people have posted those things. So, yeah. Okay, so Google. This seems obvious and then not. Maybe, I don't know. It's especially if you don't know where to start. Maybe you're like, all right, I have a question, but I kind of don't know what my question is. So we'll go through some hints for search terms for using Google, but also for using other resources. Okay. So first of all, try rephrasing your question. Sometimes you're like, I want to know how to order things, and you're searching ordering, and you're getting a lot of complaining on Yelp as your research, your stuff that comes back. If you are maybe it's 2 in the morning and you've been looking at this thing for 6 hours and you're like, I just don't know what you would call it besides ordering. Go to thesaurus.com. They are awake all the time and they will help you figure out another word. So that's if you can't think of any other words, ask the internet to help you. Paste the whole damn error message. Maybe it's really long. Whatever. It doesn't matter. People have done it before, and you will find their conversation about that exact same long, inscrutable error message. So, next, Wikipedia. Sometimes you're interacting with somebody else's code or some other thing, or someone's like, you should use celery, and you're like, hey, it might be 2 in the morning, but I'm not shaking a vegetable at my screen. I know that's not going to help. But if you put celery plus programming into Wikipedia, you find out that it's this asynchronous task queue, job queue thing that happens to be open source, so you can just use it, which is cool, but it's called celery. So you would get a lot of bouquet garni before you figured out that you had to put plus programming or plus Python in there. So, like pickle, for instance. Do you guys know what pickle is? I don't know if we have mostly intro folks or, okay. For a long time, I thought it was a brined cucumber. It's not. It's also this mechanism for object serialization, which you might have tried to look for as ordering, but maybe not. But so now you know when you've seen people talking about pickling and unpickling and you thought it was a Python channel and you're like, these people are so off topic and hipster. Like, is everyone making pickles at home or what? So anyway, try plus programming plus Python. If you find one of those words where you're like, they can't really be talking about pickles. Okay. So, like I said, use lots of words. Don't forget to put Python or programming or both in there when you're searching, especially when you're using Google to try and get the answer to a programming question. These are links. I'm not going to insult your intelligence by putting URL for Google up there. This one I didn't talk too much about. It's the Python module of the week. It has a lot of like really nice in situ with code snippets. So if you've been like kind of skirting a module and thinking that it might be something you want to use, you can go to this website and see how other folks have been using it. So, project-specific questions. Maybe you've decided to jump like full in. You're like, I'm going to learn Python and I'm going to contribute to like a free or open source project. Hooray! I'm so psyched for you. But you're going to end up with project-specific questions. And there are places to find those answers. I'm hoping that you were picky when you chose a project and that they have documentation. And I'm hoping that you were lucky enough to find one that has good searchable documentation. So first, check the project-specific docs. Next, you might want to search the bug tracker. Sometimes something doesn't work, not just for you, but for everyone. So don't bang your head against the wall for a really long time. Make sure that it's supposed to work, and then you can move on. Next, most projects have like a IRC where you can go chat with folks on the internet, or a mailing list. And we're going to talk a little bit about how to phrase your questions to get the best answers out of some of those resources. Also known as dudes on the internet. So sometimes you're like, I have a question, and you're imagining like someone on the other end, like maybe you read that weird Eric Raymond thing about how to ask smart, oh holy smart people for questions. I don't think you have to go through all of that. You will sometimes find snotty people on the internet. I'm not going to lie to you. It will happen. But the more specific your question is, the better your answer is going to be. And there's also something like a little bit counterintuitive about the way that you talk to people on the internet. So, yes. So like, say I was going to try and get Ned to help me move this weekend. Right, so first I'd be like, hey Ned. And you'd be like, hey, how's it going? Are you around this weekend?
Yeah, sure, what's up?
Yeah, I was just, I don't know if you still have that truck. I need some help moving.
Oh, look at the time, I gotta go.
Yeah, no, but, and you know, I still have 4 sofas. Plus, there's a can of warm PBR in it for you, right? So, but on the internet, you don't like ease into it like you would IRL. That's in real life. You would just jump right in. So there's no like, hi, how's it going? Like you just jump in. You just kind of say what it is you want. Specific is better. Like a post titled "Using Wrong Library" versus difference between C++, random number generation, and Python. Which one do you think is going to get a better response? The first or the second? Second, right. Of course. Because there's nothing here. This is what's going to get the snotty response, like, oh, what library are you using? Like, it's like if you ever put anything up with a typo on it, and you don't get the people who are interested in whatever it says, you get people who like to point out typos. So it's kind of like that. So the more specific you are, especially in the subject part, the better of a response you're going to get. Loads and loads and loads of details. If you think it's relevant, put what version of Python you're using. Let's see. If there are other programs involved, especially if you're like writing something that's constantly calling to a database, you should mention what kind of database that is in your question. or like some kind of web framework. If you're using Django, like say Django, it's going to help you out. It's also, you know, just the more context, the more picture, it's going to give people a better idea of what you're trying to do. What have you already tried? This is going to help you in 3 ways. 1, you're not going to get the response to try the thing that you already tried, which is great. That keeps it from wasting your time. 2, it lets people know that you did already try stuff, and then they're a little bit more motivated to help you because they know that you've tried some things. Also, in the course of trying some of those things, like if you look and you're like, oh, I know everyone's going to ask me to try this, this, and this, and they seem really obvious, and you know that's totally not the problem. But sometimes you do all those things and you discover that you have solved your own problem. So that can save you a lot of time. I've definitely done that. I've been like with Stack Overflow open, like writing a really detailed, like, and then I tried this, and I'm like, oh wait, I should first actually try that. And I'm like, oh, okay. So put down what you've already tried, you'll get a better response. And whether it's mailing list, IRC, Stack Overflow has like a way for you to specifically to paste code in. But if you're talking to folks on the mailing list or on IRC, either paste short snippets or use something like Pastebin. So like especially if it's an IRC channel where it's like, oh, like really busy, chatting all the time, paste a link to your code so it doesn't get broken up with like, whoa, look at this thing I found on Twitter, you know. So and that also means that, you know, people can look at it and maybe edit it as well and be like, oh, look, if you just change the order, you're fine, whatever. So, quick recap. I know I'm like standing between you guys and beer now, so.
Free beer.
Free beer even. So, quick recap. Ask the right question in the right place. Remember, we have our buckets and they all have their own areas. There are places for nearly every question. Almost everything has an FAQ, a tutorial, something. And then verbose, when you're doing your question asking, is always going to be better and always going to yield a better result. Here are some of the books that were recommended to me. These were specifically as folks were saying, like, I refer back to this book all the time. So I have not read all of them. So I hope you guys feel a little bit more happier about the prospect of going out and asking questions to get help as you learn to program. And I will now answer your questions about questions. Yeah.
You should recommend Symbol Hound too, because Google will strip out periods and hyphens and things, but Symbol Hound keeps them.
Oh, Symbol Hound. Okay, so Symbol Hound will help you get better results when you are searching for stuff on the internet. Cool. Anyone else? Yeah.
The only other thing that I do when I'm stuck like that is I get up and I walk over and I talk to someone else and explain my problem to them. And then now I don't even talk to people. I just walk over to like a poll and I just explain it to the poll. And then I'm like, oh, thanks, poll. And then I go back and fix it. It's just like the act of explaining. It's like you're writing the
right, writing the really intense verbose question on Stack Overflow. You can do that without typing, apparently, says Ned. You can, sorry.
You look weird.
Yeah.
But you do it. Talk to poll.
Yeah, I assume that's when Jessica's not home.
Yeah. I talk to Jessica. It's great.
I'm constantly talking to myself in the other room. He has to ask me periodically if I'm talking to him or to myself. It's usually myself.
Talking to yourself or inanimate objects in your home. Anything else? Any other stuff? Yeah?
We're going to put all the slides
on the meetup page.
on the event page.
Yeah, I will share them on the slideshare.
And don't overlook, we have our own IRC channel, Boston Python on freenode.net.
So if all of that, like if that was TLDR or TLDL, listen, whatever, you can just come visit us on the Boston Python channel and say, where should I ask this question? And we will, you know, if you ask nicely, we'll tell you.
Cool. So as a couple of more plugs related to the meetup, if you want to practice getting help with your questions, a really good place to do that is our monthly project nights. You can get help in person as well as on the internet. If this IRC thing sounds pretty cool, but you're not sure how to get started, we can help you get set up at the project nights. I'm going to put these things out there if you want to grab some stickers or some notepads on the way out. And other than that, it is time for Mead Hall. Thank you all.
Free beer!